Hello viewers, in this video we are going to see about how to design a FIR filter using Fourier series method. Here, in this problem, the specification is given as HD of e power j omega is equal to 1. The frequency is greater than less than pi by 3 and greater than minus pi by 3. The response is 0 for the frequencies greater than pi by 3 and less than pi. Determine the impulse response h of n for n is equal to 9. Here the number of samples is 9. Determine h of z and magnitude response. So based on the given specification, you have to identify the type of the filter. In the question itself, it is given it as a low pass filter. Okay. So if it is not given, so you have to identify what is the type of the filter. So to identify the type of the filter, you have to draw the response from the given specifications. Step 1. Plot the response. So in this problem, the specification is given as 1. That is, it is symmetrically about 0. That is e power j omega n. N value, if n value is equal to 0, that thus the magnitude is equal to 1. If n is not equal to 0, that is, it is not symmetrical about 0 and it is symmetrical about somewhere the values of the n. Okay, it is symmetrically about 0. If it is symmetrically about 0, the magnitude is equal to 1. Okay, here the response is the bandwidth is from minus pi to plus pi, which is symmetrically about 0. So from the specification, the frequency is greater than minus pi by 3. Here, the greater than minus pi by 3. And it is less than plus pi by 3. It is less than pi by 3. The magnitude, that is hd of e power j omega, the magnitude value is 1. So from this, from the given specification, it is identified that it is an low pass filter. It is a low fall filter. Step 2. So what is the step 2? You have to find the desired response. So how to find the desired response? So we have the relation to find the desired response, that is hd of n is equal to 1 by 2 pi. Here the bandwidth minus pi to plus pi, so 1 by 2 pi minus pi to plus pi hd of e power j omega into e power j omega n into d omega. So this is a relation to find the desired response. 1 by 2 pi, here the response is between minus pi by 3 and plus pi by 3. Minus pi by 3 and plus pi by 3, and hd of e power j omega. hd of e power j omega value is 1. So 1 into e power j omega n into d omega. And do the simple integration process. That is 1 by 2 pi integration of e power j omega n with respect to omega, that is e power j omega n divided by n, that is jn. The integral value is pi by 3, the limits is minus pi by 3 to plus pi by 3. It is equal to 1 by 2 pi e power j pi by 3 n minus, that is by subtracting the lower limit, e power minus j pi by 3 n divided by j n. You know the formula, that is e power I theta minus e power minus I theta by 2 is equal to I sin theta. Okay, here the relation is e power I theta minus e power minus I theta divided by 2. Here we have already 2 pi jn. I am going to write it as an e power j pi by 3 n minus e power minus j pi by 3 n divided by pi n and then 2j. So this value is equal to e power I theta minus e power minus I theta by 2 is equal to I sin theta. That value is equal to, that is 2i is equal to sin theta, that is sin n pi by 3 divided by pi n. So this is the desired response. So step 2 over. So there is an easy way to compute this desired response. That is, the frequency response is from minus pi by 3 to plus pi by 3. To find the desired response, that is sin n pi by 3 sin n pi by 3 divided by n pi. That's it. Sin n pi by 3 divided by n pi. That's it. Okay. So we found the desired response. Next we have to find the actual response. Here step 3, that is the actual response. So what is in that actual response? Here the desired response is of infinite in duration. The desired response is of infinite in duration. Here, to find the actual response, we are converting this infinite duration into finite duration based on the number of samples. That is truncating the infinite sequence of HD of n to the 9 samples. Here in our problem, the sample is given as an n is equal to 9. That is the truncating the infinite sequence to that n samples. That is truncating. To find the truncating infinite sequence, that is HD of n to the given sample is 9 samples. So n is equal to 9. So what are all the n values? So n is equal to 0 to n minus 1 by 2. That is n is equal to 0 to n minus 1 by 2 is nothing but 8 by 2, that is 4. So n values is equal to 0, 1, 2, 3 and 4. We are going to find the actual response for different n values. That is n is equal to 0, what is the actual response? For n is equal to 1, what is the actual response? For n is equal to 2, for n is equal to 3 and n is equal to 4. HD of n is equal to sin n pi by 3 divided by n pi. That is, to find the actual response, that is the h of n is equal to sin n pi by 3 divided by n pi. N is equal to, if n is equal to 0, h of 0 is equal to sin 0 divided by 0 into pi. It is 0 by 0. It is undefined. It is undefined. So you have to apply L'Hospital rule. You have to apply L'Hospital rule. That is in differentiating numerator and denominator with respect to n. So that is a differentiate numerator and denominator with respect to n. That is limit n tends to 0. Sin n pi by 2, when you differentiate sin n pi by 3 with respect to n, it is pi by 3 into cos n pi by 3. And similarly denominator n pi, it is pi. So at n is equal to 0, that is cos 0 is equal to 1. That is pi by 3 pi. So the answer is 1 by 3. Okay. So h of 0 is equal to 1 by 3. So when you divide 1 by 3, it is equal to 0.333. So you can find either by using the L'Hospital rule or by directly you can find the value for h of 0 by integral value, that is h d of n is equal to 1 by 2 pi integral minus pi by 3 to plus pi by 3. So e power j omega n to d omega. So in that equation you can directly substitute n is equal to 0. That is e power 0 is equal to 1. That is for 1 with respect to omega. So 1 by 2 pi minus pi by 3 to plus pi by 3. So e power 0 is equal to 1 d omega. So 1 by 2 pi integration of 1 is equal to omega pi by 3 minus pi by 3, which is equal to applying the lower limit minus pi by 3 divided by 2 pi, which is equal to 2 pi by 3 divided by 2 pi, and this value is equal to 1 by 3, which is equal to 0.333. Either you can follow L'Hospital rule or you can directly apply 0 to that desired response value. In that you can find the HD of n value. In L'Hospital rule, you have to differentiate both numerator and denominator separately and apply the n is equal to, apply the limit n is equal to 0. So for that you have to find the h of 0. Next you have to find h of 1. H of 1. H of 1 is equal to sin pi by 3 divided by pi. So sin pi by 3 divided by pi, you keep your calculator in radian mode. That is sin pi by 3 pi is equal to 0.276. H of 2 is equal to sin 2 into pi by 3 divided by 2 pi is equal to 0.138. H of 3 is equal to sin 3 pi by 3 divided by 3 into pi. 3 get cancelled, sin pi is equal to 0. And h of 4 is equal to sin 4 pi by 3 divided by 4 pi is equal to minus 0.069. So step 3 over. Next one is you have to find step 4. Step 4 is to find the transfer function h of z, which is in non-realizable form. The relation to find the transfer function h of z is equal to h of 0 plus summation n is equal to 1 to n minus 1 by 2 into h of n z power n plus z power minus n, which is equal to h of 0 plus summation n is equal to 1. Here the n value is 9. So 9 minus 1 by 2, 8. That is 9 minus 1 by 2 is 4. H of n into z power n plus z power minus n. So you know that we have already found the value for the response for different h values. That is h of 0. h of 0, for h of 0 it is 0. For h of 0 it is 0.33. h of 1 it is 0.276. h of 2 is 0.138. h of 3 is 0 and h of 4 is minus 0.069. So we are going to substitute these values, that is the filter coefficient, in this equation. So h of 0 is equal to 0.333 plus h of 1 is 0.276 into z power 1 plus z power minus 1 plus 0.138, that is h of 2 value is 0.138, z power 2 plus z power minus 2 plus here h of 3 value is 0 and then h of 4 is minus 0.069, z power minus 4 plus z power plus 4 and z power minus 4. So this is the transfer function of a FIR filter which is in non-realizable form. Next, we have to convert this non-realizable form into a realizable form. That is step 5. So step 5 is you have to find h of z which is in realizable form. So how to convert this non-realizable form into realizable form? That is, you just multiply the transfer function is of non-realizable form into z power minus n minus 1 by 2 into h of z. So which is equal to z power n minus 1 by 2 is 4 into h of z value is 0.333 plus 0.276 into z power 1 plus z power minus 1 plus 0.138 z power 2 plus z power minus 2 minus 0.069 z power 4 plus z power minus 4. You just multiply by z power minus 4, it is equal to 0.333 z power minus 4 plus 0.276 into z power minus 3 plus z power minus 5 plus 0.138 z power minus 2 plus z power minus 6 minus 0.069 z power 0 plus z power minus 8. So this is the transfer function of an FIR filter which is in realizable form. So from this realizable form, you have to obtain the new filter coefficients as h of 0. So from this h of 0 is minus 0.069. h of 1, what is the h of 1? That is h of 1 is 0. So there is no delay element. So 0, the h of 1 is 0. h of 2 is 0.138. That is the filter coefficient. h of 3 is 0.276. h of 4 is 0.333. So after conversion it into a realizable form, my new filter coefficients as 0 minus 0.069, 0, 0.138 and 0.276 and 0.333. Next step is, step 6 is to find the frequency response. Step 6. Step 6 is frequency response. So how to find the frequency response? That is h of e power j omega is equal to a of 0 plus summation n is equal to 1 to n minus 1 by 2 a of n into cos omega n. So this is a relation to find the frequency response of the system. So what is, how to find a of 0? A of 0 is equal to h of n minus 1 by 2. A of n is equal to 2. 2 into h of n minus 1 by 2 minus n. Okay. So by using this relation, you have to find the new filter coefficient, that is the frequency response. That is a of 0 is equal to h of n minus 1 by 2, that is h of 4. That is, so from this you have to pick. So what is the h of 4 here? So h of 4, the new filter coefficient has been arrived from the realizable form. That is a of 0 is equal to h of 4. It is equal to 0.333. A of 1 which is equal to 2 into h of n minus 4 minus 1, that is h of 3. 2 into h of 3, that is 2 into 0.276. 2 into 0.276. So a of 0 is equal to h of 4, it is 0.333. A of 1 is equal to 2 into h of 3. So h of 3 is 0.276. That is 0.552. And similarly, a of 2. A of 2 is equal to 2 into h of 2. H of 2 is 0.138. So 2 into 0.138 is 0.276. A of 3 is equal to 2 into h of 1. 2 into h of 1 is 0. A of 4 is equal to 2 into h of 0. That is h of 0 is minus 0.069 and this value is equal to minus 0.138. So we found the filter coefficient as a of 0 is equal to 0.33, 0.552, 0.276, 0 and minus 0.138. So from this you have to find h of e power j omega is equal to a of 0. A of 0 is 0.333 plus a of 1 0.552 into cos omega plus a of 2 plus 0.276 cos 2 omega plus, here the next filter coefficient is 0. Next minus 0.138. 3 omega is 0. That is the n value. For n value it is 0. For n is equal to 4. That is cos 4 omega. So this is, in this way you have to find the frequency response. To find to plot how to plot for different omega value. So choose the omega value from 0 to pi, that is 0, 0.1 pi. Choose the omega value from 0 to pi, that is a 0, 0, that is a 0.1 increment, 0, 0.1 pi, 0.25. For different pi values, omega value, find the value for h of e power j omega and then plot. I just summarized the entire process of designing the FIR filter problem. The step 1 is Based on the given specification, draw the response. Minus pi by 3 to plus pi by 3. Next, step 2, find the desired response. By the relation 1 by 2 pi minus pi to plus pi hd of e power j omega into e power j omega n into d omega. So after finding the desired response, find the actual response. That is truncating infinite sequence into desired, that is the finite sequence. That is in the given problem it is 9 samples. So that n value is equal to 0, 1, 2, 3 and 4. Then for different n values, find the actual response. If you put n is equal to 0, it is an undefined. Okay. So apply the L'Hospital rule, or put n is equal to 0 in the desired response and find the value. And for different n values, find the filter coefficient. Next, step 4, find the transfer function which is in non-realizable form, that is non-causal filter. H of z is equal to h of 0 plus n is equal to 1 to n minus 1 by 2 h of n z power n plus z power minus n. From this it is 0.33, 0.276 and so on. And similarly, realizable form, you just multiply by z power minus n minus 1 by 2 into h of z. So from that realizable form, we have to arrive the new filter coefficient. H of 0 minus 0.69, h of 1 0, h of 2 minus 0.138, h of 3 0.276, h of 4 0.33. Next, you have to find, the last step is you have to find the frequency response. The frequency response is h of e power j omega equal to a of 0 plus summation n is equal to 1 to n minus 1 by 2 a of n into cos omega n. A of 0 is equal to h of n minus 1 by 2 and a of n is equal to 2 into h of n minus 1 by 2 minus n. So you have to pick the actual response after the causal filter. A of 0 is 0.33, A of 1 is 0.552, A of 2 is equal to 0.276, A of 3 is equal to 0 and A of 4 is equal to minus 0.138. So from this final answer, h of e power j omega is equal to 0.33 plus 0.552 into cos omega plus 0.276 into cos 2 omega minus 0.138. Thanks for listening. Thank you so much.